Okay, so first of all, I extend my sincere gratitude to Masai for giving me the opportunity to be the part of this project. Today, I'm going to explain about my project. My project name is Car Resale Price Prediction System, and the overview of this project is it takes factors like brand, model, year of manufacture, mileage, fuel type, and engine volume. Location is not there in my data set, and it predicts the value as per these factors. Okay, so I take the data set from Kaggle, and if I try to see you the raw data set, then it is the raw data set which I took from the Kaggle. Okay, so first step that I did is exploratory data analysis and handling the data and preparing the data to give to my model. And yes, so first of all, I perform EDA part, which I'm going to explain you. So I imported the relevant libraries and the raw data set, and then I use describe in here. I include all. That is why categorical values are also present in the describe function. Here I drop the model column because it has 312 unique values, and if I convert it using get dummies, then it exponentially increases my dimensionality. So that is why I removed the model column for now for my linear regression model. Then I check is there null value present in my data set or not. So here you can clearly see. So I just applied the rule of thumb law. If it is less than 5%, just remove them. For sure, you can do imputation also, but I uses that method. Then I plotted the probability distribution, the chart where you can see that. So here you can clearly see that it is 1, 2, 3, 4, 5, 3 lakh. So it must be outlier. So car price prediction. So first of all, I have to deal with the outliers also. So for that, I removed the 1% outliers and take the 99% of the data. I do the thing with the price column. You can clearly see now it is 12 lakh. Earlier it was now it is 1 lakh 20,000. Earlier it was 3 lakh. Similarly, I did with the year, mileage, and engine volume. You can clearly see that engine volume cannot be 100, and it must be below 6.5 liter, right? So I also handle that. I also handle the outliers in the year column. And after that, almost many some rows has been removed. So uh, it impacted my indexes. So I just reset index. And again, I use describe, and you can see that, and just saved as a car clean CSV. So on that note, I will further do feature engineering for my linear regression. So you can clearly you know that Here you can clearly see that for linear regression, we need a sort of linear relationship between the feature and the target column. But now here you cannot see any kind of relation. So that is why I performed log transformation here. And after that, some sort of linear regression is there. Not exactly. And you know that in real world, there is no exact linear relation in data, but some sort of linear relation is there. So now I can do that. I also checked the multi-collinearity with the help of VIF, and after I found that it is greater than a 10, so I just removed the year column, and then I converted the categorical columns into numerical one by just get a means function, and now my data is ready and I saved it as car preprocessed. So I will train my linear regression model on the same data. So here you can clearly see that I read that particular data that I have recently saved, and my target price is a log price and my features are all other columns. Before that, I also done the scaling because with the help of standard scaler, because it increases my model accuracy, and I apply train test split, and then I just train the model. And here you can see that how my model is predicting on the Y train. And this is the PDF graph for residuals. And here is the R2 score and root mean squared error. Now just I evaluated my linear regression model, and this is the predicted versus the actual log price. But then I figured it out that some good models are also there. So then I tried a random forest on that data. Then I trained the same data on a random forest, and random forest takes care of categorical values itself. So do not need to convert it. And here again, I to use train test split uh, method and the random regressor method, and I keep my model name as RF1, and then I just wait. Now you can see that my model is predicting fairly well as compared to linear regression, and this is on testing time. Yes, there are some deviation while testing, so I just do the hyper parameter tuning for 3 times, but ultimately I found that the best model that I have in all of them is base model of random forest. So I just choose that one because the difference is far minimum than all other models that I have trained. So that's about the model training part. And then I will walk you through the data visualization. Then I just made the dashboard using Streamlit. Just wait a minute, it is loading. Okay, so here is my model. You can clearly see that. So here you can put the different feature values as per your requirement, and then simply you can predict the values. Here you can see that if I select the Audi, if I select the Toyota, then the brand, as per the brand, the model is giving just for that particular brand. If I select the Audi, then it will give all the models of Audi. So it is kind of a very good feature. And then you can predict. So here is 42,000 is the value for the used Audi A6 petrol version car. So that's about my project. And thank you for listening me patiently. And thank you once again. Have a nice day.